Hello everyone and welcome to part 4 of the Car AI series. In this part we're going to make the car drive. Let's dive into it and have some fun. The thing where we stopped at the last part was the wheel colliders. We made sure that the wheels are turned in the right direction, depending on where the next waypoint is. So the car is already pointing to the right one, but now it needs some power to go there. Open up the car engine script, and as for all main features we're going to make a function for the movement. So in your fixed update, call a new function and we will name this function drive. Then we're going to make this function, so make it private void drive. And in this function we're going to add some torque to the wheels just to see what happens. So we take our wheel front left and we set the motor torque to around 10. Also do this for the other one, wheel front right dot motor torque equals 10. Save the script and let's see what happens. So we can see that the car is moving towards our waypoint. It's turning and now it's going directly to the point. Okay, so now we know that motor torque is the engine of our wheels. But now the car is only going to the first waypoint. Do you remember that we have the current node and that we never changed this? So it will only steer towards our current node. So actually the thing we want to do is calculate the distance towards our node, and if we are very close to the node we go to the next one, so we increase the current node. So when the distance is very small we increase the variable to take this one, and then it's going to steer towards this, and then this, and then this, so it goes in a loop. For this we're also going to make a new function just to make everything clear. We call this function check waypoint distance. Also make this function, so private void check waypoint distance. Here we're going to say if the distance to the waypoint is smaller than a number, we're going to set the current node to the next one. So to do this we write if vector3 dot distance, and in between the brackets we say our current position, so the transform dot position, and then we go to the nodes array and select our current node, and from this node we say the position, because nodes is a transform array. So if you take the current node then we can take the position. Then we check if this number is less than, say, 0.05. And if it is, then we increase the number of our current node. But if it's the last one, we should set it to 0. So first we need to check if it is the last one, and if it's not, then we increase it. So if current node is equal to nodes.count minus 1, because this is an amount and this is an index, then we say current node equals 0, and else current node plus plus or plus 1 is the same. So let's save this and have a look. Wait, first let's increase the motor torque a bit, because this is way too slow. Let's say 50. And also let's say this will be 0.5, because otherwise it's maybe too less difference. So we should be at the first one. Yeah, now we go to the second one. And you can see if it's at the when it's reached the current waypoint, it goes to the next one. Okay, so our car is now driving. Let's set the camera to a fixed position. So drag it outside of our car. And let's place it somewhere a little higher. So with this view, then we duplicate our car. So we have a few of them, and let's play. So now all the cars are driving to the first point, and if one reach it, then it goes to the next one. So we are coming there. Let's create some better code. First we add a new variable, and this will be the public float max motor torque, and we default this at, say, around 80. So this is the maximum power the engine can deliver to the wheels. Let's use this number also in our code. So instead of 50, we say max motor torque. So if we're driving, we're giving the full motor power. But this is only the power that the engine has. And we also want to know the speed of the car. So make a public variable for that also. Public float current speed. Also make a public variable with the maximum speed. And we default this at, say, around 100. Then in our drive function, we're going to calculate the current speed. And if it's below the maximum speed, we're going to apply the motor torque. And otherwise, we are not giving power to the engine, like a real car. So I'm just going to give you the formula. And this will be our current speed equals 2 times math.pi times our wheel front left in this case dot radius times our wheel front left dot rpm. Then also the thing you want to do is times 60 divided by 1000. So this piece of code calculates our current speed based on how fast the wheel is spinning. And now the thing we can say is if our current speed is less than our maximum speed, then we will apply our motor torque, and else we copy this and we set the motor torque to 0. So if the speed is below our maximum speed, then we apply some torque, and otherwise just let the car roll. So let's see this in real life. As you may have noticed, the wheels are not spinning, only the wheel colliders are spinning, as you see at the green wheel. The wheels itself just stay at their position. That's because the wheel colliders are not attached to the wheels. We have to do this by script. In the next episode we're going to cover this, so that the wheel spins at the speed of the wheel collider and also turns at the right direction, because the front wheels need to turn. Also suspension will be covered, so that the wheels are a little bit bumpy. Thanks for watching this part, and I'll see you in the next one.